All right, so now that we're starting recording, we're going to pretend like I did not mess this up because people showed up late and are playing with their phone instead of actually doing what they're supposed to be doing. But you ain't heard it from me because I ain't one to gossip. Just kidding, I will gossip about you. I'll talk about you later. Okay, so we're going to put this into our calculator, which is 2x plus 5. And let's take this, and we're going to use the calculator. So go ahead and clear the calculator, and we're going to put in a new function. So clear it. To clear the calculator, how do I do? How do I clear the scratch pad? Doc B, there we go. Doc B. Let's go to my function, 2x plus 5 or minus 5? Plus 5. So now I have a neat graph there. And now that I have this function there, I can go through and start entering some values because I want to see using the limit process of what this is approaching. Because I can't always just plug in a number to see what I'm going to have. I'm going to have a hole like we did on our warm-up. So currently, I'm just going to go and I'm going to turn on the trace. Graph trace right there. Bam. Now I can start entering numbers. What was the first number that I had? So I'm approaching 2. So I start with really close with 1.99. So 1.99. There we go. And I get a number of 8.98. So plug that into your notes. The 8.98. It is, what slide is that? I don't have a slide number on this one. Yeah, so on this one, so it's 8.98. All right, let's do the next number. So the next number I had was 8.99. Oh no, wait, 1.999. So I already have graph trace on, so 1.999. I get 8.998. Four nines. This one right here is 8.9998. Now let's go to the other side of this. Go to the other side. Let's start over here, work our way towards the 2. 2.01. I come up with 9.02. Now it's 001, 2.001. $9.002. Now it's 3 O's. $9.002. Now, by looking at the pattern here, I could see I numerically found out to see where this is, because if I had a problem like I did on my warm-up where it does not exist at that number, that's what my limit process actually solves for me. This one is approaching what number? If I look at the left side, it looks like it's going towards 9 the closer I get to that. Look at the right-hand side. The right-hand side is also going down. When I'm going to 2, it looks like it's going to 9. So both sides are approaching the same number. So the limit process, it has to approach from the left-hand side and the right-hand side the same number. And this one is going to be 9 because this one works out all nice and neat, right? Because this one is not undefined at that point. Does that make a little bit better sense, or is that just chaos? Yes?
So when there would be a hole, how would it like look from the left side and the right side of the graph? Would it just still be approaching a number?
Do you want to take a look at that?
Yeah.
Okay, let's use the same problem we had on our warm-up. So my warm-up problem said, so I'm just going to clear this out. So doc B and so control divide, dang it, control. I gotta use a keyboard for this, sorry. So that one was x squared minus 2, right? Over x minus rad 2. That was the same thing, right?
Pretty sure, yes.
Yeah, minus 2 and minus, okay. And we found out that so radical 2 is 1.414. But does it keep going on? Yeah, because it's irrational. Rad 2 is irrational, so it's going to continue to go on. So right here, I'm going to start actually plugging in numbers to the left of this and then to the right of this. So the left of this, I'm going to do let's say 1.40. And C, and remember we got to turn on menu trace 1.40. Okay. So I get 2.81. So that's still on the left-hand side. Let's do another one. So 1.41. 1.41. There we go. Ooh, it's getting closer. And 1.42. It's closer. And right here, so it should be between, if I look right here, 1.41 and 1.414, right? So in between my 1.41 and my 1.42, that's my radical 2 in there, right? So if you notice, it did not, because I was actually just using approximations there. So I did get values in between that on both sides, right? So I can get closer and closer and closer by going to like the hundreds place, the thousands place, and just keep getting closer to my number of radical 2. So let's go ahead and do that. Sometimes you might have to approximate, or sometimes you have to have an actual answer where I plug in my radical 2. There's my undefined. So I know on the left side of this, it's getting, that's my 1.41. The right side of this would be approaching on this side. 1.42 would be right here. So 1.42 is the right side. 1.41 would be the left side there. Because rad 2 is right between those two numbers. So it's going to look like that, and sometimes you're going to have radicals, sometimes you have decimals. In AP Calculus, we always use 3 decimal points. So if you're going to approximate this, you would approximate to 3 decimal points whenever you have a chance. Make sense? Okay, good. All right, good question. All right, now, left hand, right hand. With the graph I actually showed you, as my limit is approaching, it came from the left-hand side, it came from the right-hand side. Here's the notation for this. To the C minus, that means that is I am taking my limit to the left, okay? Sometimes you might only need to look at the limit on the left. Sometimes there's problems that do not exist. The domain does not exist after a specific number. So you can't plug in any numbers beyond that. So right here, so that would be from the left. Here's another one from the right. So with the plus sign, it's going to be approaching from the right-hand side. That's important because these things, when you see those symbols above those, that's going to mean either left or right. Now, for a limit to exist, the definition of a limit, you ready? The definition of a limit says for it to be a limit, it has to approach from the left and the right to the same number. Left and right, same number. Here's another one. I want you to try this example. So here is an example for yourself, the one that is not going to exist. Because I can't just plug in 0, because that would be 0 in the denominator. Okay, try it out. You get it yet, Tree?
No, I'm just relearning some stuff.
Relearning what? Just plug in the calculator. I'm going to show you the whole thing. Yeah, you're not that far yet. That's L'Hopital's rule.
I was there.
Huh?
I was there before.
You was there? Oh yeah, back in 6th grade, right?
No, if I was over this. It's fine.
All right, I'm going to enter this one in now. E to the x minus 1 over x. Doc B. There we go. All right, so along with this, I'm going to show you a new thing to go along with this. So instead of doing the regular trace, I'm just going to go table. Split screen. And then you could scroll through to see where it's going. But if you notice, it's not really going close enough, is it? All right, let's see. There you go. So I added some dots here to my graph to make this one look a little bit better. So you could actually see it's happening right here. It should be between these two numbers, 0.632 and 0.718. I already know it's going to be undefined there. So that's one way of actually going through and setting it up to try to actually figure those out. So the calculator is super smart. Now we can start entering this, and let's go back to this and do my graph trace. Okay, we know at 0 it's undefined, so the numbers I was using was it on the negative 0.01? So negative 0.01. Put in my numbers. Keep going. Negative 0.001. Negative 0.0001. So it's getting really, really, really close. Now, since this calculator is super smart, if you overload it by getting super, super close, it will round it off anyway. So from the left-hand side, what does it look like it's approaching here? 1. Okay, so let's try it from the other side. The other side would be, what do we say? So it's going to be 0.01. So 0.01. There we go. It's the other side of 1. 0.001. 0.0001. Let's keep going. 0.000000001. There you go. So if you notice, I got my calculator to do an overrun on that. So it's so close to 1, it approximates it, and the calculator just shows me 1 now, doesn't it? So it's still undefined, but it's close enough that the calculator says it's going to 1. There you go. So we know we're going to have that as 1. Now this one right here is going to be good. So let's try this one. So it's approaching 0, sine x over x. This one's going to be a good one. Let's clear everything. Doc B. So start over again, because every time we do this, you want to start clean. I hit trig button right here, the trig button right below control, sine x, close, over x. And this is where a lot of people have trouble. They'll give me dirty looks, be like, what the hell, mine don't look like that. Why is that? Huh? Radiant. How do you change to radiant? So watch this. See where mine says rad? Use your mouse, go click on it. Now it says degree. Just click on it and it switches back and forth. All right, so we're trying to approach 0 this time. Totally forgot to actually, here, I'll do this. So name and then calculate our numbers. The one I gave you, so I could actually make sure that's signed for everyone. All right, so we're gonna use the table again. Menu, table, split screen, and we're approaching 0. Just by looking at the graph. This is one way of actually trying to do this. What do you think my answer is going to be? What you got? 1. Yeah, it is 1. Okay, so now, does it meet the requirement? What was the rule I said about limits? Left and right side. Is the left and right side both approaching 1? Yes, they are. So guess what? So the limit of this one is going to be 1. This is by analyzing the graph. We could see, and if you look at the table there, you know, I'm showing for that one, but that goes in increments of single increments. I'll later show you guys how to actually change all the settings if you want to modify your table. Okay, we did this one. Here is the rule for the limits. So, like I said, for a limit to exist, the left hand and the right hand both need to go to the same number. Now, the first one over here on the left, this is actually going to be the left hand and right hand both go to that limit, which is the limit is C. So the limit is that number. Now, this next one right here is going to be the limit is approaching, but what does the open dot mean on your line graph? There's a hole right there. That's a hole. So the left side and right side are both going to that number, okay? But it is the limit right there. It's not going to be equal to because it does not exist. But the limit exists, but the function does not exist at that point. And then, same thing goes for here. So, left side, right side goes to this one. Okay, so right here it says, notice in figure 11C that H is not defined at C, but the value of H gets closer to number L, significantly close to C, suggests that the limit of function as x approaches does not depend on the value of it existing of the function at C. Now, if you look at the second one, what's different about the second one? Slightly different. It's kind of hard to see on the thing. That's why I wanted to turn off the lights on this one. The limit exists and the function exists. If you notice, it's way up here. So, is my line continuous? Once it gets to this point right here, there is a different function. This is kind of like a piecewise function. It exists, but it's way up here. So, the line is not continuous, so we could say that the line is discontinuous here. It still has a hole right there, but the function goes up here. So, but the limit still exists. The limit is still going to be this point right there. All right. All right. Now, use your graph to do this one. So I want you to try this. And so 3x plus 1 and 10. Let's do it piecewise. Doc B. And x not equal to 2. X not equal to 2. This other one's 10. And this is x equals 2. Now, did I do that too fast, or do you want to go back over it?
Yeah.
Okay, so to get the piecewise, remember the little button right here below delete? It actually brings up the little different little icons to enter. So I entered a piecewise right there. So there's my piecewise, and there's different piecewises. That this one with the comma gives you the restrictions of whatever your domain is. This other one does not. So it'd just be two different functions going together, just graphing them together. There we go. And then part of your argument, oh crap. Damn it, did I mess that up? I did, didn't I? So I'm gonna do it again then. There we go. Why do you not like me? There you go. So 3x, was it 3x minus 1? Plus 1. And on the other side of comma, I put my argument, so x, and right below control, you'll see an equal sign. That's your equal symbol, not really equals. So, and control equals is going to bring up my little, all the different symbols. There's my not equal to 2. Go down the other one. 10. And where x is going to be equal to 2. All right, let's see. X is equal to 2. When x is 2, should be 10. It's right here. So, menu. Analyze. There it is, my graph trace. So, and go, boom. There we go. Start going over. There's 1.5. 2. It's way up here, isn't it? It's off the line. It's off the line. It's right there. And then if I keep going, it's back down to here. So even though this does exist up here, because it doesn't exist for this function at 2, it's still going to be the limit, which is going to give me 7. Yes? No? Do you understand why? You're not? Okay, good. Let's see. So, for this function, can I plug in 2? Okay, because this is a piecewise function, it says that it does not exist at 2. So, if I'm following the line right here, okay, and if I'm tracing this, this is going to go close as it can, and it will be 7. It goes to 7 from the left-hand side, and then from the right-hand side, it's also going to 7. So I don't know if you can see it here. So it does do it. It does show on this one, so that you could actually have 7 there, even though it doesn't exist on that one, because there's 2 functions for that. And then just keep going in both directions. It's approaching 7 from both sides, even though it did not exist for my piecewise. That's just like this second function here. So it exists way up here. It didn't exist on the line because the line had a hole. But because a limit is not saying that, it's saying left side, right side, going to what number? And that was 7. Alright, where am I at? Okay, that's what it looks like. Let's see, where are we at? Yeah, before we get to all those, I'm going to leave off right about here. And then we're going to look at our assignment for today, so you guys could get started on these assignments, which is right here, our homework, section 1-1, 1 through 6, 17 to 28, 31, 35, 37, 8, okay, and all AP practice. Now, these ones right here are important, but if you notice, I'm giving you the full homework assignment, and we haven't even finished the notes. So you guys could start on this, but you're only going to be able to do a couple of them, but I want you to be able to practice what we did right now. If you don't practice what we did right now, you're going to get lost. I don't want you to do that. All right, make sure you guys all like, share, and subscribe. Hit that notification button. Support my channel. Buy stuff for the merch store.